Welcome. You're about to listen to a presentation by Dr. Nikola Blagojevic, researcher at the Chair of Structural Dynamics and Earthquake Engineering at ETH Zurich. The presentation of Dr. Blagojevic was part of the program of the 5th panel organized by CHARE, as part of the panel series Turkey and Syria after the earthquakes. His research focuses on the development of novel tools for regional resilience assessment and post-disaster reconstruction modeling. His current work involves developing tools for hospital resilience assessment. In addition to his academic work, he collaborates with the insurance industry to enhance tools for business interruption loss assessment. Dr. Blagojevic is the lead developer of the open-source Python software for regional reconstruction simulation and resilience assessment, FireCode. He holds a PhD from ETH Zurich and a master's and bachelor's in civil engineering from the University of Belgrade, Serbia.
Thank you for the introduction, Gamze, and thank you for the invitation to this event. I'm really happy to be here. And hopefully my comments would help with planning the reconstruction of Hatay. So what I'd like to start with is this slide here, where I would like to touch upon what I work, and then from this perspective, I'll provide some comments on the report. I think what's important to understand is that disasters cause damage, and no matter how much we try to engineer our buildings to be robust, we always see that there is some damage. Whether it's floods in Germany, earthquakes in Japan, Turkey, or Haiti, we have to admit that this is inevitable. And what we can try to think about is how we can recover quickly from this damage. And this is where the concept of resilience comes in, and this is central to my research. What we try to understand is how we can design and build our infrastructure and buildings so that they can quickly restore functionality following a certain disruption. And when we face such questions in engineering, what we like to do, we like to develop mathematical models or computer simulations of our structures and then play around with them in this virtual space to understand what is the best course of action to make them robust. And when it comes to our built environment, we sort of have the tools to do this for this initial drop in functionality. We have the tools to assess damage and predict damage and mitigate damage. It's something that Shafak and Professor Taskin were all talking about. But what we lack, if we really want to be resilient, we lack tools that can help us plan reconstruction in a better way so that we can do it quickly and we can build back better. And this is something that I've been working on here at ETH with my colleagues for the last 5 or 6 years. And so what we came up with is a software which can simulate the reconstruction of cities following disasters based on different urban planning decisions. And here you can see how reconstruction of Northeast San Francisco would look like after an earthquake, conditioned on different availability of workforce. And we can also synchronize this recovery with the recovery of infrastructure. We can see how long people will be out of their homes, and all of this is conditioned on different resource allocation strategies, different financing options, and different urban planning decisions. And what we do in these kinds of softwares, we perform what-if analysis, and we ask ourselves what would happen if we would do this or that. Then we simulate this and we see if this is the output that we would like to see in real life. And we've also applied this to real life case studies where we try to, first of all, simulate an event. So we simulate ground shaking, simulate potential damage, and we simulate reconstruction and see what happens. Or we can also apply these tools after a disaster, where we collect damage data, and then based on the damage that we know, we simulate reconstruction. And we compare our outputs with what actually happened on the ground, and we see what we can predict and what we cannot predict. And together with Shafak, we were in Turkey in March last year, and we are trying to understand what's the best way to reconstruct this region from our research perspective. And one of the things that we're looking at now is when is it better to retrofit buildings and when is it better to demolish and rebuild those RC buildings in Antakya. And so from this perspective, this is how I viewed the report, trying to understand how this reconstruction would look like once it starts. And what I really liked about the report is that it's very comprehensive. There are many dimensions which are considered, which is, I think, a great foundation for the future. And one of the things that was mentioned is participation. This was also, I think, highlighted by previous speakers. And this is crucial for successful recovery. People need to be engaged in the decisions that are to be made regarding reconstruction. But my comment would be, how do we include people that moved out from these cities? Because we know some first estimates were 1.5 to 3 million people that were displaced. Some of them left the region. If we want them to come back, how do we include them in the discussions if they're not physically present on site? My other comment would be about recovery guidelines, which are mentioned in the report. And I think this is very important because it's these reconstruction procedures from a building owner's perspective of view, they have to be clear so that so that they can be executed efficiently. And Maria shared with us Miyamoto's repair guidance, which she also mentioned. I think this is a very good initiative. But for example, after the Croatia earthquake, there were some guidelines which were similar to those from Miyamoto, but were more broader. So in those guidelines, depending on the damage that your building experienced, there is a clear set of steps which you need to follow. And every step is explained. What documents do you need? Who do you need to ask? Is this going to be is the state going to provide financing support for this or not? And I think these kinds of guidelines might be helpful also for reconstructing hut. Another thing that I also liked about the report is that local materials are preferred. This is mentioned in the report. This is important for the economy of the region. But what I'm thinking about is that the local supply won't be sufficient, especially when high-intensity reconstruction efforts start. What we saw when we were there is that there were a couple of construction facilities that were damaged in the earthquake. So maybe focusing on rebuilding them in parallel with the recovery would also be a good thing because this would increase the local supply of materials and would also help these people get some jobs and get back to their normal life as soon as possible. Infrastructure resilience is something that was mentioned in the report. I think water and power systems were mentioned. What I would like to add to this discussion is interdependencies. What is often missed in engineering considerations is that when we talk about power, water, gas, communication systems, they all depend on each other to operate. So if you have a single weak link, it might happen that all the other systems fail. So for example, even if you invest in ductile pipes or base isolation for components of the water system, but all of these rely on a power system, which is not that robust, in a disaster, you might have a drop in the functionality of the water system because of these interdependencies. So thinking about backup generators or some other measures of reducing these negative interdependencies, I think would be also important. And I'm going to be quick. This is the final slide. What I also really liked is the report emphasizes that these reconstruction efforts should be such that Hatay is more resilient to future disasters. I think floods were mentioned, landslides, liquefaction, and of course earthquakes. And here what I would like to emphasize is that when we talk about resilience, we're talking about a continuous process. So even if we reconstruct Hatay now and it's resilient now, as the city is expanding and aging, its resilience is going to change. And what we need is continuous resilience monitoring. So one of my suggestions would be to maybe think about instituting something like a chief resilience officer of a city or a city resilience officer. This is something that is becoming more and more popular in the world. So there is an office which is only concerned about implementing actions and plans that make sure that the city is always resilient to different disasters. And I would stop here. Thanks for listening, and I'll be happy to contribute to the discussion.